Hi all, a very good morning. Just give me 2 minutes, so we'll start with the session. So in the part of our yesterday's class, we started learning about the NAT, that is Network Address Translation. So quickly reviewing on the things that we put across yesterday. We recreated the complete VPC once again, and then what we did, we have actually launched one EC2 instance in public subnet and one EC2 instance in the private subnet. So we had recreated the VPC once again, and then we started launching a couple of instances. So one instance was launched in the public subnet, one instance was launched in the private subnet. And then we saw that this specific IP address range, which is being assigned here 10.0.1.0/24, from this, one of the IP address was being assigned to this instance, and one of the IP address was also assigned from 10.0.2.0 to this private instance. And we see that the instances which are in the public subnet can be connected from outside the world, but instances which are in the private cannot be connected at all. So how do we log in into these private instances? So first I have to log in into public instance, and from public instance I'll be able to log in into the private instance. So that is the only way we can do it. This is because, now if you refer to this diagram, because these two buildings are in the same compound. So if I'm able to go to this building, from this one I'll be able to go inside this one. And then we got a case scenario where the instance in the private subnet wanted to talk to the internet in order to get the update of the software, right? So how did we enable it? So there are two different ways. One is either NAT gateway or other is a NAT instance. So we learned about what is NAT gateway in our yesterday's part of our class. We saw that how NAT gateway helped in to get access to the instance in the private subnet. So today we are going to learn about the NAT instance. But before that, I'll have to again recreate a scenario of having the two EC2 instances, one in public subnet, one in the private subnet. So let's quickly go ahead and spin up instances. So we are in the Mumbai region. I'll quickly go ahead and navigate to IC2 section. I'll open the VPC section here. So I do not have any instances. I'll quickly go ahead and launch a couple of them, one in the public subnet and one in the private subnet. So I'm going to select the Amazon Linux AMI. And then the instance type is going to be of T2 micro. So what is the change we found here? So since we have launched our own VPC, I'm going to select that. So I'm going to pick up AWS training as a VPC. And the subnet, we have two subnets. One of them is a public subnet, one of them is a private subnet. So why do we call it as a public? Because it has internet gateway attached to it in the route tables. And the second one doesn't have any internet gateway attached to it. So I'm going to first put across in the first one, that is 10.0.1.0, so that I'll be able to access it from the internet. Now I have to enable the IP address so that I'll be able to log in into this EC2 instance. I'll quickly go to the next, add storage, and then add the tags. So I'll give the name as my public instance because I know that I'll be able to connect from the internet as it is a part of the 10.0.1.0 bar 24 subnet. And quickly putting it back behind the SSH security group. And then launch this. So now what I have done, I have launched one EC2 instance in the public subnet. Similarly, let's go ahead and launch one instance in the private subnet. So again, I'm going to set the Amazon Linux AMI. And then as a part of our free tier, we are going to pick up the T2 micro, which has got one virtual core of CPU and 1 GB of RAM. Again, we are going to launch it on our own VPC, this time in 10.0.2.0. And again, let me show you, even if I enable the public IP address, I'll still not be able to log in into it because we know that there is no way from the internet I'll be able to access this private subnet, because in the route tables, we have to define route in case we want to communicate with this instance, which is in the private subnet directly over the internet, right? Then there's no point of creating a VPC if I'm able to connect it over the internet. So that's the reason we create our own private clouds so that people outside the world will not be able to access it at any cost, right? So we are trying to secure the complete environment. So here the route tables are the one they are controlling the complete traffic. So I'm going to go ahead and launch a private instance in the private subnet. I still enable the public IP address just to showcase that still we are unable to connect to this EC2 instance. We'll go ahead and add the storage, 8 GB of size with general purpose SSD type of volume. And then I'm going to go ahead and add the tag. I'll say name my private instance. This one also is going to be behind a security group where we have the port number 22 opened up. I'll quickly go ahead and review and launch this, and then go ahead and launch. And I acknowledge the key pair that we already have, that is Mumbai key pair. There we go. So we have launched one more instance in the private subnet now. So let's connect to the public instance in the meantime and see what is happening. So I have the public IP address. I'm going to make use of this. So there we go. It is asking me to verify the key fingerprint. I'll say yes, and then login as EC2-user. So I am into my EC2 machine. Let me increase the size of the font here. Okay. So we are inside the first machine. Let's go ahead and elevate our privileges first. There we go. I'm now at a root user. So let's say if I want to go ahead and update, make some updates here. Let's see if it is able to connect to internet. So from internet we are able to connect, and from instance we are now checking out if it is able to access the internet or not. Yeah. So we have logged inside our EC2 instance. So from outside the internet, we are able to connect to this EC2 instance. Now we are going to check whether from this EC2 instance I'm able to connect towards internet or not. So I'll say yum update -y and see if I'm able to get updates. There we go. I'm able to get all the updates for this EC2 instance. So it's working fine in both the cases. So if you refer to this diagram here in the paint, so this gate which is towards the 10.0.1.0/24 subnet is helping not only the outside world to access this instance, but this EC2 instance can also access the things outside the world. So there you go. Now let's check out what's happening with the private instance. I'll just go ahead and copy the public IP address. So I'm going to click on open. So we have selected the private instance here, and now we are just trying to log in inside this. You see, it says network connection, network error, connection timed out. I'll say okay. So this is a proof that even though we assign a public IP address to the EC2 instance, if it is a part of private subnet, right? So if it is a part of private subnet, no one will be able to access it outside from the internet at all. Now, the case is fine. From outside the world, people will not be able to access it. But my instance, which is inside the private subnet, requires access to internet. Now, if there is a house inside this specific building, let's say some people are living, they want to survive, right? So they may want to go out, they should be able to access the outside world to get the vegetables or something else, right? So in order to themselves survive, we need something to get them, help them get connected to the market. But outside the people cannot come inside this premises at all. So how do we help these instances in the private subnet get access towards the internet world? So that is where we are trying to make this red colored line, which is actually called as NAT, that is network address translation. So in our yesterday's class, we did see how to set up a NAT gateway. In today's class, we are going to see how to set up a NAT instance. NAT gateway is pretty simple, as we yesterday saw. It is just a 2 steps and we will be able to create it. The NAT gateway, NAT instance is something that we little lengthier to set up. So we are going to do that today. So the step 1 here, it says that I need to first create a security group for NAT. But before that, let me tell you how do we log in inside the instance which is in private subnet. Now we all know if I'm going to get access to this compound, this complete 1 acre land from this gate, I'll first get inside this public subnet. Now from public subnet inside this house, I'll be able to connect to this another building. Okay, so what we are going to do is I'm already inside this EC2 instance. It is 10.0.1.108, which is a private IP address of the instance. This is my public instance which has got a private IP address of 10.0.1.108. Now let's check out what is the private IP address of this. It is 10.0.2.38. So since they are in the same arena, I can use the private IP addresses to communicate between each other, right? Since they are part of same VPC, I'll be able to communicate. So already I am inside this EC2 instance. So let me communicate to this one from here. So how do we do it? If you remember, we are in the Linux box. So the command that I'm going to use is ssh -i and then the key pair. -i is basically the identity. So what is the identity we are going to pass? The key pair, right? And then I'm going to log in into the server using the username as ec2-user at the rate IP address of the EC2 machine. So first thing is I have to go ahead and create a key pair. Let's go and create a key pair. So I'll say nano Mumbai keypair.pem. So I'll pick up the file from here. So I'll go down to my E drive, key pairs. So I'm going to pick up my PEM file. There you go. I'm going to pick up the complete contents, pull it across into my file, Control X, Y, and enter. So we have saved it. If I say ls, I'm able to see that this is a file with Mumbai key pair. I'll have to first change the permissions for this. chmod 400 Mumbai keypair.pem. So I have changed the permission successfully. Now let's log in into the server that is in the private subnet. So I'm going to say ssh -i is basically identity. I'm going to use Mumbai key pair. So the username is ec2-user at the rate 10.0.2.38 is the private IP address. There we go. See, it is immediately asking to verify my key fingerprint. I can say yes, and there we go. We are inside the machine that is a 10.0.2.38 and the name currently is at ec2-user. Let's go ahead and elevate the privileges. Now, if I go ahead and try to get the updates from the internet, let's see if it works. So it should fail because we know that the instance from the private subnet doesn't have direct access from outside the world, nor it can access anything which is available outside, right? So we have to help this EC2 instance get the access towards the outside world, not the outside people to get access to this instance, but the instance to get the access towards the outside world for getting these updates. Now, why do we require these updates? Let's say tomorrow you are going to spin up a database or maybe something else which is private to your company. Let's say you are going to host a web server which is private to your company itself. It should not be accessible to anyone else. Like, let's say it's my company's internal portal, right? Of course, it does run on some of the web server. It could be like HTTPD Apache, or it could be a Nginx, it could be a JBoss, or it could be any other web server, right? So it needs to be installed, it needs to be getting updated all the time as per the latest internet standards as well. Just that I'm hosting a website which is internal to my own company, I'm not exposing it to the outside world, but I require a software for that, right? That is like HTTPD or Nginx or JBoss or something else. So for that reasons, we are going to help these instances in the private subnet get access towards the internet so that it will be able to fetch the updates from the outside world and install them automatically into this one. However, the people from outside world will not be able to access it. So NAT is just a bridge for helping the instances in the private subnet get access the internet, not the people from the internet getting access to the instance. It just works one way. Okay, so we see that we are unable to update the security patches. Now we are able to install it. Let's try to see if I'm able to install something. I'll just say httpd -i. Right, so it doesn't work. So we are now going to set up a NAT instance, which is going to help me in this complete case scenario. So let's get back to our steps of NAT instance. So here are the 6 steps in which we'll be able to achieve this. So the step number 1 is I am going to go ahead and create a security group for the NAT. So let's get back to our EC2 console. I am here. I'll go scroll down a little. In this, I'll find out the security group section. I'm going to go ahead and create a new security group. I'm going to name it as NAT security. And again, I'm going to give the same name, NAT security. And it's going to ask me which VPC this is going to be part of. Remember, security groups are limited to VPC. So each VPC will have its own set of security groups. So whenever you're going to launch an instance, it's not that you already have a security group and you will be able to use it. You need to have that specific security group in that VPC. Then only you'll be able to put it across, right? So currently, if you see, in 1 second, I'll just show you. Okay, so here in security groups, when we go down, you'll be able to see that I'll have a lot of security groups, but they are pertaining to their specific VPC, right? So for the default VPC, I have got all the security groups, and for the normal ones, I have got only 2 of them yet, right? The VPC that we have created with the name AWS training has got only 2 security groups at this point of time. So as a part of our NAT instances, the step 1 is to basically go ahead and create a security group for the NAT. So I'll just go down to this one where I given the name of security group as NAT security, and I'm going to put it behind the AWS training VPC, and then just go ahead and say create. Now the step 2 is about setting up the inbound and the outbound rules for this security group that we have just created. Let's go back to our security group, open up the NAT. Okay, so currently we do not have any, so I'm going to set up the inbound rules. So by default, as we all know, outbound will have all traffic, all ports, everything open. That's fine. So I'm going to go ahead and set up the inbound rules. Now in the inbound rules, what should happen? So my source is instance in the private subnet. So I'm going to keep it as custom. So I'll say 10.0.0.2.0 bar 24, right? So this is my source from 10.0.2.0 source. It should go outside, right? So where should I be able to go ahead? I'm going to use HTTP protocols. Remember, all our web packages are usually available on the HTTP and HTTPS protocols itself. So if you want to download any software today, what would you do? Specifically, we'll go down to HTTP protocol or HTTPS. That is, I'll go down to this website somewhere else. I'll say, like, let's say I want to download Ruby. So usually this is available at this specific point, right? https:// www.rubylang.org/en/downloads, right? Similarly, all our protocols are available for the download on HTTP and the HTTPS. So I'm just going to open up the 2 ports, that is HTTP and HTTPS, for this 10.0.2.0 bar 24. So I'm going to keep this. So this is the source from where the traffic is going to originate. towards the HTTP and the HTTPS. I'll go ahead and say save. So there we go. So 2 steps are done. So we created a security group for a NAT, and then we have updated the inbound rules. Now the third step is to create a NAT instance. So let's see how do we create it. So I'll go back to the instances section. Click on launch instance. So what I am going to do in here is, now I will not be able to use Amazon Linux AMI here. I need to have a NAT instance. So where do we find it? I'll simply go to the community AMIs, type here something is called as NAT. So you'll see that there are a lot of instances with the NAT which are already available. So I'm going to pick up the very first one. So for this general purpose T2 micro free tier is available. So I'm going to pick this up. Now the main thing starts up here. So whenever you're going to create a NAT instance, the first part was choosing it from the community AMI, and second is we are going to create in the VPC that we have created. So let's select that. So I'm going to put it in the AWS training VPC and place this EC2 instance in the public subnet, and IP address should be disabled. So I'm going to put it in the public subnet that is 10.0.1.0 and ensure that the public IP setting is at disable. We do not need a public IP address for this, right? So what did we do? The most important steps, I went ahead to create a NAT instance using the community AMI. I have selected the NAT, and then I'll try to launch a VPC. In the VPC that we have created, I'll launch this instance, put it in the public subnet, and then IP address was disabled for this, right? I'll quickly go ahead and say add storage. I'll go with 8 GB of size. I'm okay with the magnetic type, and then I'm going to put it as name will be my NAT instance, and then I'm going to configure the security group. So I'll say select existing security groups. Remember, we just created a security group some time back, that is NAT security. I'll select this, which has got HTTP and HTTPS ports opened up for the traffic that is going to get started from 10.0.2.0 bar 24. So I'll go ahead and say review and launch. So it is going to tell me that since you have not opened the port 22, you will not be able to connect to this EC2 instance. That's fine. We are not going to log in inside the NAT instance. NAT instance is just a bridge helping the instances in the private subnet get access towards the internet. So I'll just go ahead and say continue. And it's asking me, would you like to go with magnetic? Yes, I'll say continue with magnetic itself. So there we go. This is our complete EC2 instance section. So what did we do in this part here before I launch it? Whenever I'm going to go ahead and create an NAT instance, I need to ensure 3 steps. One is choosing the AMI from the community section by selecting a NAT, and then launching this NAT instance always in the VPC that we have created, that is AWS training, and always put this into the public subnet. Let's check out if we have put it across the public subnet. I'll just check it from here. So it says it's subnet BC0DDDB4. I'll just re-verify it. Yeah, it is 10.0.1.0, which is BC0DDBD4. And we have ensured that the IP address is also disabled, and we have attached it to a security group that was created in the step 1, that is NAT security group. Right now, quickly I'll go ahead and say launch instance. I'm going to use the same key pair. So this NAT instance is going to take a couple of minutes again to get started. So there's one step that we have to do once the instance is up and running. So that is about disabling the source destination check on the NAT instance. So we are going to disable the source destination check. There we go. Our instance is already up and running. I'll select this NAT instance. How do we disable the source destination check? I have to go to the actions. go to the networking part, and then you will see change source destination check. I'll click on this. So they're asking me, are you sure you want to disable the source destination check for this instance? So I'll say yes. Now why are we disabling this? Since, as I said, this is only a one-way traffic to be helping with us, right? So we are only helping the EC2 instance in the private subnet to get access towards the internet, right? We are not helping the people from outside world to get access to this. We are just helping this NAT instance to get access to the outside world. So this is going to be only one-way side. So I'm going to disable the source and the destination checks. So we don't want to create any checks on any side of this area, right? I have disabled the source destination check. Now this next step is I have to go ahead and update the route tables. So let's go quickly down to the route table section. I am already in the VPC. I'll click on route tables. So I'm going to check out where my private subnet is. My private subnet is still a part of main route table of AWS training VPC. Remember, from subnet associations, you will be able to see it. The 10.0.2.0 is still associated with the main route table, and inside this we do not have any access towards the internet gateway at all, right? So yesterday we created a NAT gateway. So currently it has become a black hole because we have deleted the NAT gateway. Let's go ahead and remove the NAT gateway, and I'm going to add a new route. So I should be able to connect to any place in the world. That should be 0.0.0.0 bar 0. That is destination. Destination can be anything. I can go anywhere. And using what? I should be using the NAT instance this time, right? Yesterday we used NAT gateway. Today we are going to make use of NAT instance, and then I say save. So now my private subnet has got access towards the internet using this NAT instance. But there's one last step that we have to put across before we can see that the updates are available or not. That is, we need to create an elastic IP address so that the IP address of the EC2 instance doesn't change. Remember, why do we use elastic IP addresses? It is to have a persistent IP addresses. So I'm going to click on elastic IP. I'm going to go ahead and request one. There you go, I got it. I'm going to go ahead and associate this one with one of our EC2 instance. Remember, yesterday we attached it to a network interface. Today it is going to be a part of instance. So I'm going to attach it to a NAT instance. And then I'll quickly go ahead and say associate. There you go. We have been successfully able to associate it. Right. So the NAT has now got this instance. Remember why we assign the elastic IPs, so that even though we restart the machines or do something, these IP addresses are not going to change. Usually the public IP addresses for any instances usually change off whenever we are going to restart the machines. Okay, so now we are almost at the final step here. Now I am already inside this private instance, that is 10.0.2.38. Earlier we just saw that we didn't have any access towards the internet. It was giving me error saying that this doesn't have access or something is wrong. So now I'm going to go ahead and clear the screen, and then I'm going to go ahead and update, put the command yum update -y. Let's see if it has got access to internet or not. So there we go. We are now able to access the internet from this EC2 instance, and we are able to get the updates, right? So we are being able to set up this bridge, which is red in color, which is now actually helping the instance in the private subnet access the outside world and get the updates. We'll also try to install some softwares on this. Let's see if it is working very much fine. let me try to say yum install httpd -y. There we go. I'm able to install it. I'll try to install some more softwares. I'll just say php -y. See, we are able to install everything on this instance which is in the private subnet. So that was about the concept of a NAT instance, right? So any questions here from any one of you, Shiva, Rahul, or Divya? How about you, Divya? Are you able to follow it up? Okay. Now we all know that the instance which is in the private subnet, right? Even though we have assigned a public IP address, this one is a public IP address. You know that even if I try hard after setting up the NAT instance, let me try it out. I'll just put it here. I'll go down to the SSH auth. So even if I try to open it from my machine, it will not work because we have just given the access of internet to the instance, right? From the inside world, right? From inside the instance can communicate to the internet, but from internet people will not be able to connect it. We'll see that it's still going to get timed out. Yep, there we go. It's going to get timed out. So we have been able to set up the security very well in this case here, that the instance in the private subnet has got access towards the internet with the help of NAT instance, but not the people from outside world will be able to still access it. So if I have to access it, how do I do it? I have to first come towards the instance in the public subnet, and from that public subnet instance I'll be able to log in inside this instance which is in the private subnet. That is the only way I'll be able to access this EC2 instances, right? So that is where the concept of so we have a new concept that is called as bastion host. So we are now going to learn what is a bastion host. So bastion host is basically a way to help us access the instances in the private subnet, right? So if I have to access the instance in the private subnet, that is only way is the bastion host. Okay, so we learned about the NAT, which is helping the instances in the private subnet access the internet. So now there's a small concept that we need to learn about Bastion. So how are we trying to log in inside this instance in the private subnet? We are actually first coming inside this public subnet. From public subnet, we are trying to get inside this private, right? So that is, there is one EC2 instance already underlying here, and from this EC2 instance, we are trying to access this instance in the private subnet, right? So we call that as basically a bastion host. Now why we call it as a bastion host? Bastion host is otherwise actually called as jump box, because we are trying to use this box and we are trying to jump over and then try to access this EC2 instance. We also call it as a jump box. So what is specialty about a bastion host? Now what happens is, let's say these are the instances in the, there are certain instances inside this public subnet. Okay, we all know that public instances are specifically exposed to outside world, as well as outside world will be able to access them as well. So here I'll be usually hosting my e-commerce website or something, or websites which are usually exposed to the people. Like it can be Flipkart, it can be Amazon, it can be Paytm, it can be anything else. Now I do not want people to use Paytm website and log in into this, right? That's not a security measure. So what I'm going to do is I'm going to specifically set up a box. Okay, I'm going to specifically set up this box here, and this box will only have the SSH port opened up. These boxes which are used as a websites will never have any SSH ports opened up. This will have only the ports 80 and port 443, that is SSH, sorry, that is HTTP and the HTTPS ports opened up, right? So these will not have any SSH ports opened up. So we are going to open up only the HTTP and HTTPS for the normal web servers. For this Bastion host, I am going to open up the SSH port, and that SSH port will be available only to the administrator of the company. Let's say I am the admin of the complete VPC section, right? So it will be available only for me and my team members who are supporting along with me on this VPC build, right? So only they will have access, and that too only my company's IP addresses will be a part of this security group. So it will be like, let's say this public instance, I'll coin it as Bastion for a while, because we only have a security group which has got SSH to be opened up on this, right? Currently it says SSH is currently open to complete world. No, it will not be. For Bastion host, what happens? This will be termed as a Bastion, and then the security group will be opened up only to a certain section. Let's go and do it. So let's say my company's IP address range is something like the place where I sit. So let's say the place where I sit, I have a certain set of IP address range, maybe like 15.15.102.0 bar 28 I'll give, or you can give bar 32. If you give bar 32, it is going to refer to only one IP address. If I say bar 28, so remember the calculation formula, what happens here? 2 power 32 minus 2 power 28 is going to give me 2 power 4, that is going to become 16 IP addresses. So basically I'm trying to say that there will be 16 IP addresses in this specific range who will have the access towards my internet, right? So for now I'm just going to keep it to my IP address. I'll keep it little simple. So what I'm trying to do, I'm trying to open up a EC2 instance which is accessible only over SSH, and this instance is accessible only to me from my IP address, right? I still have 4 different EC2 instances in this public subnet which are opened up as an e-commerce website like Flipkart, Amazon, or something else. But from these EC2 instances, we do not have SSH port open, which can help you to access this, right? So we are restricting that access. So I'm going to create a bridge. I'm going to create a bridge towards this building to this building, specifically from this place itself, right? So only this instance is going to have that access. So if you are able to get inside this building, you need to have access to get inside this specific house. Only then you will be able to get building. So I'm going to create a bridge from this specific house towards the private building, right? So that's what I've done. So only I have the authority to go inside this EC2 instance because it is limited to my IP address. So whenever I'm going to enter inside this building, I'm going to show the security guard that I am exceptional case, I am coming from this IP address. So the moment I say this IP address, he'll say that okay, you can go to this specific floor where the bridge is available. Now when I come to this specific house, I'll be able to show my exclusive IP address and the private key, and then I'll be able to go inside this, right? So if I go inside this, I'll be able to access the instances in the private subnet. So that's why we now call it as a Bastion host. So Bastion host actually comes with a certain certain security, right? So I'm opening up the SSH port, but it is opened up only to a specific company's IP address or the set of administrators who are going to work on this VPC, right? Or maybe my private IP address as well. Okay, my IP address, that is, I can just say. Okay, so if I'm the administrator of this VPC, I'm just going to open up this port only for myself, right? So this is about a bastion host. So what does a bastion host basically do? Bastion host is helping to get inside the private subnet. And what does a NAT do? NAT actually helps the instances in the private subnet get access the internet. Remember the difference, what is between the NAT and the bastion, right? So NAT is from EC2 instance towards internet, and bastion host is basically from internet. If someone wants to connect, they will not be able to do it directly, but only the company's administrator, I'll just say admin, helping the admin people to get inside the EC2 instance, right? So when they go to their office or when they are working from the home, only that specific IP address is opened up, and only the people from that IP address will be able to log in inside this SSH box, which is actually called as bastion host. And from there they are going to connect to the instance which is in the private subnet to configure the software. So now when I'm configuring the software like I was doing just now, that can be done when they have connection to internet. How are we going to achieve that? Using the NAT. So any questions here on the bastion host? Okay. Now, the next part that we are going to pick it up in the section of VPC is about security. We all have learned about security groups. We have been playing around with it whenever we launch our instances. But if I want to secure my complete VPC itself, how do we do it? So that is where we come across this network access control list, that is NACL. So the network access control lists are the way we are going to control the access. Now, whenever I'm going to create a VPC, automatically a default NACL will be created. You see, two subnets are already associated with this network ACL, and this is a default NACL for the VPC with the name AWS training. So each VPC will have one default access control list already available. Now, if I go ahead and create one more, I'll just say my custom NACL, and I'm going to create it for AWS training VPC, and let's say create. Right, so it has created for the VPC AWS training, but it says it is not a default one, right? So there can be only one default NACL which gets automatically created the moment I create a VPC. So always remember, whenever the VPC is created, two things automatically get created. One is route table, that is main route table, and the second is NACL, which is a default NACL for any VPC. Also, a default security group also gets created. Remember, right? So for AWS training, we also have a default VPC which is already existing. So let's put it here. right? So we'll have these three things automatically created. Now let's go down to this specific section of NaCl. And remember, we have two subnets, and currently when I have created a custom NaCl, I do not have any subnet associated with it. So if you refer back to this diagram, now NaCl is at a specific subnet level. So currently, whenever we create a VPC, there will be one NaCl which is applicable across all the subnets which are a part of this VPC. Now let's say I want to control the access to the public subnet separately and the private subnet separately. So I can divide the NaCls into two parts. So I have just created my custom NaCl now. I can go down to my custom NaCl and click on subnet association and click on edit. And I can see that I want to control the traffic for public subnet from this custom NaCl itself. So you can click on save. You will see that now only one subnet is a part of the default NaCl, and one subnet is actually part of the custom NaCl that we have created. So 1.0 is actually part of custom NaCl, while the 2.0 is basically a part of default NaCl, right? And if you check out the rules, inbound and outbound rules of the default NaCl, you see that everything is allowed, right? It says all traffic, all protocols, all port range allow, and same is the case here. All traffic, all protocols, all port range allow. Now, if you see, we basically write the rules inside this NaCl as same as security groups, but in this case, we also have a parameter which says whether I want to allow or whether I want to deny, right? So in security groups, it is only open up a specific port, which means it is only allowed for traffic. It doesn't deny any kind of traffic. So if I want to deny a traffic, I can do it at a network ACL level, that is network access control list level itself. And here in network access control list, we always write the rules in the multiples of the 100. So if I have the rule number 1 at 100, then the rule number 2 will go at 200, and then followed by 300, 400, and 500. So we are going to learn in detailed portion in tomorrow's part of lab. Why do we write it in the multiples of 100? The rules in a specific network access control list, right? So this was just an introduction to the NaCl, what happens in here. So we just saw that the default NaCl automatically exists for our VPC, and we can create our own custom NaCl, and we can tag a specific subnet to that custom NaCl. So whenever I'm going to make a tagging of a specific subnet, so you can see clearly that one subnet is now, there are overall two subnets in my VPC. One subnet is automatically associated to the custom NaCl and the other one is associated to the default NaCl, right? So if you check out for the other one, the default VPC, which is already available in the Mumbai region, all the two subnets are basically part of the default NaCl table itself, right? And we just checked out what is the subnet associations. We checked out what are the outbound rules and the inbound rules basically available for the default NaCl, right? In the custom NaCl, we have just created it, so there will be no rules. So currently it is all deny, right? So currently it's denied. We are going to learn about it in tomorrow's part of lab in very much detail on what we are going to do with the NaCl. So any questions or queries before we close the session for the day? Yeah. Okay then, so we'll end off our session here. And before we close the session, remember, once you are practicing all these things in the VPC, remember VPC is free, but the instances that you're going to launch are inside this VPC are going to be chargeable. So just go ahead and ensure that you clean it up, or else it is going to unnecessarily put across the load on your AWS account. Practice the labs well, and remember elastic IPs are also chargeable in case if you do not use them. So once you are done with the lab, remove of those elastic IPs as well. So if you forget to remove it, you're going to be getting the charge, right? So first thing is you have to first dissociate the address and then straight away go ahead and say release the address. So once I say release, it is being released off, right? So always do the cleanup activity well. so that you do not have any problems with your AWS account in terms of the billing. Thanks all. Have a great day, and we'll meet back again tomorrow at the same time.